All right, welcome everybody. I hope audio is working now. Do you hear it? Okay, very good. I'm sorry for the delay. This modern setup is not as easy as we thought. No, I've just struggled with some audio issues, but it should work now. And just raise your hands if the audio will disappear again, so we notice very fast. It is an honor and a pleasure to be here today with you and present Smart Coolant Management to you. I hope you are not too comfortable in front of your screens, because I would like to involve you into this presentation, so we have an interaction between each other. And so I'm not only talking to a camera, and I also get some feedback from you. And therefore, I would like to quickly also do a technical test now with our polls. We will ask questions during the presentation. And the first question will pop up right now. You might have to agree on some terms and conditions from Microsoft if it's the first time you use it, and ask you to do that and quickly answer the first question. So this is just to test, nothing else, and it should be easy to answer for every one of you. So far we already got one vote. I hope we will see more. Just wait a few more seconds. Yeah, this is starting to move. So we have one from Asia and one from Europe. Are there more people voting? It would make the interaction much more interesting. Let's see. Wait a bit more, one more. You literally just have to click yes, yes, then vote. It should not be a big deal. All right, so I'll hope with the next question more people will be ready to answer. I would like to continue, not that we stare at this poll the whole afternoon. So yeah, what a crazy year or more. Last week I had the great chance to go back to a football game. I know we have people from North America, so we call it football, you call it soccer, I guess. I was able to go to a Champions League game, and my home team played last week against the, I guess, most known football club in the world, Manchester United. It was outstanding and incredible before and after the game. And I looked at some KPIs of both teams to compare who is playing against who. So on one hand, we have Manchester United worth 1 billion euros. And then we have the Burnley Young Boys worth 60 million euros. And if you look at the players from Manchester United, especially Paul Pogba, the fifth most valuable player of Manchester United, his market value is as high as the entire team with 30 people of the Burnley Young Boys. So here you can see KPIs, they are very, very interesting and in sports, and they are also very interesting in our industry. And maybe to inform you, the result at the end of the game, in the last minute, the Young Boys scored their second goal and won the game 2-1, which was mind-blowing and one of the best sporting experiences I've ever had. But enough about football. Let's go to the topic KPIs. So I want to ask you in the next poll, what do you think is the most important KPI in a metal cutting company, like in the factory? So I kindly ask you to, if you haven't done it yet, sign or click on the terms and conditions from Microsoft so you can participate. I would be very interested in your feedback on that. And also here, I'll wait a few seconds so you can participate. So we have the 2 votes from before. Let's see if we can rise it up to 3. Hey, great. This is improving, but the results seem to be very difficult. Huh? We have quite a draw there. There one more coming in. Yeah, I guess not. However, thank you for your vote. And it is interesting. I mean, we have everything here. We have productivity, we have process stability, we have EBIT, profit. They're all valuable KPIs. But I claim that the most important KPI for a machining company is the concentration of the coolant. Yes, you hear right. I'm talking about the ratio between oil and water in an emulsion. Yeah, my name is Daniel. I'm head of marketing and sales at Liquidtool Systems. 20 years ago, I did an apprenticeship as a mechanic. So I used to work on CNC machines and had my first shower of coolant there. That was a steady prank we had with our apprentices. We had this hose with the coolant facing towards the face of any operator who would start the machine, and when he starts the machine, the coolant flushes out into your face. So that was fun if you did it to someone else. It was not so fun if you experienced it on your side. I have to admit I was on both sides, so it's fair deal there. However, this didn't keep me away from this wonderful industry. On the contrary, for the last 6 years, I have been only dealing around coolant. So my everyday business was coolant, and I had the honor to talk to customers around the world about coolant management for the last 6 years. Yeah, so today I will give you all 6 arguments why coolant concentration is the most important KPI in a machining company. So number 1 of my arguments is the coolant consumption. What I have seen around the world in the companies is the waste of coolant is extraordinary. So this here shows a classic curve of concentration of the coolant. So in general, you have the temperature rises, or the temperature is there, and the coolant, the water of it, evaporates. So only the water evaporates and the oil stays back in the sun. That leads to a higher concentration. Very simple, that's why it's rising. And then after a while, you fill up the machine with a thinner coolant with a lower concentration to bring down this concentration. So it's this steady up and down on concentration. And what we see here is the area of overconcentration. And this here is pure waste of money. So, ladies and gentlemen, whenever your concentration is too high and the coolant gets out of your machine with chips or with cavities on the parts or any other ways that the coolant can get out of the machine, you are wasting a lot of money. That's my first argument. The second one is machine downtime. So here again, if you look at the coolant concentration, if you have a too high concentration, you get residues on your machines, as you can see here on these pictures. At the beginning, it just doesn't look nice, that's okay. But within time, these residues, they get so thick and sticky, they start interfering with a lot of things on your machines, especially with modern machines, with a lot of sensors on it. So they start really causing troubles on your machines, and you don't want that. And it is not nice to work in this environment, obviously. And on the other side, if you have a too low concentration, then you risk the machine you risk corrosion, because every good coolant has corrosion protection in its formulation. And when the concentration is too low, then you have only water basically in your machine, and that definitely doesn't help your corrosion. So I had customers, they had to change whole linear guides and because of corrosion. And you can imagine how long this machine stands still and are not producing parts. All right, let's go to the third argument I have for you.
Tool life. Also here, with the tool life, let's say you have a very high concentration, then you risk the case that the coolant starts foaming. So when you have foam in your process, then you don't have a super cooling effect and no lubricity effect. On the other hand, if your concentration is too low, you have basically only water going into the process, the lubricity is missing. So also here, you need to find the sweet spot to get the best out of your tools and the machines. But the impact is definitely there. And if you don't believe me, just switch off the coolant one day and machine without it, and then you will realize very fast how important the coolant is. My fourth argument is about process stability and productivity. Yes, someone chose this point, I understand. That has a high influence on how many parts you produce. So here I would like to look at the concentration in detail with you. In this example, I chose a concentration of 7%, target concentration, plus minus 2%. So that means the coolant, I want that the coolant stays between 9 and 5%. And then are 2% points higher or lower than 7. Now if we look at it from the perspective of the coolant ingredients, then it looks a bit different. You can make the math yourself. From 7 to 9%, that is 28% more active substances, and obviously on the other side 28% less active substances. And this, ladies and gentlemen, is really, that was an eye-opener to me when the first time I saw that, like this. So imagine you are machining precision parts, you have a very good machine, precise tools, fixing, clamping, everything is perfect in very low tolerances, and then you come with a coolant, once with 9%, once with 5%, and you're astonished that your series or your parts are not as precise as you imagined they'd be. The influence is massive, and if you get this under control, you can really improve your process stability and productivity. Okay, let's go to the fifth argument I have for you today, and that's human compatibility. So obviously I moved that to the further back because I think the employees are the most important factors in any company. And if we don't take care of them, we will have issues in any other state. So here, the information is, if you have a too high concentration, then you risk skin irritation. So most cooling lubricants contain preservatives that kill all sorts of bacteria. Yes, even the good bacteria that should protect our skin. So the higher the concentration, the more bacteria die off of your skin and you lose your natural protection on your skin. And that's what you need to get under control. Good. My last argument, why the most important KPI is the coolant concentration, is this one here. Employee motivation. So I made this picture at a customer about a year ago, and you can probably imagine how it smelled there when you look at the picture. was an absolute disaster there, and it was clearly only lack of coolant management there which led to this kind of picture. And here I can explain you if the concentration again here in this example is too low, the coolant becomes unstable, and bacteria, fungi, and yeasts can begin to grow. And this can then lead to such results. So who would be motivated to work in such an environment? Yeah, if I summarize the 6 points, there's another point or another angle you can look at it. There is no other element or medium in our industry which encounters or gets in contact with so many different objects like the coolant. If you think that coolant can get in contact with the machine, with the workpiece, with the tools, with the air, with the floor, and with the lungs and the skin. So you have one element influencing so many other things. Yeah, I think it's really important to look at this in detail. So, as we say, coolant management is so important, we asked 100 people in the industry how they monitor the coolant and how they take care of their coolant. And the most specific question was, how often do they measure the concentration on their machine in a workshop? And that's my next question to you, ladies and gentlemen. And I would hope for 4 answers now. That would be an improvement again. So please share your thoughts. One vote. So either the rest is asleep or all right, weekly, never. I like this answer. Are there more questions? Answers, I mean. Okay. Also here, I won't force the engagement. Thanks for answering, the ones who did. So now let's see how this is handled in the practice, how they do it. So we created a video which represents standard Western European company when it comes to coolant management. Enjoy the video and see you later.
So that's it. Oh no, I have to measure the concentration on the cooling fluid. Where's the refractometer again? Oh, that looks really dirty here. So. Oh, that's 5.5.
Oh, hi Patrick, what are you doing?
Hi, I measured the concentration of the cutting fluid.
Oh, by hand?
Yes.
How often do you do that?
Oh, twice a week, but we do not take it seriously.
Okay, and what do you do with the values?
I put it in here in the sheet.
Okay, but that looks very serious here. I mean, there are no gaps, and almost every day, every third day, you have a measurement.
Yeah, I fill the gaps with the values from next time.
So when you forget, you just fill it in the next time,
Yeah.
so it looks clean. I understand. And what, so 5.5. 5.5, that's a bit low, huh? Did you maybe forget the refractivity factor?
Oh man, yes. 5.5, yes. And the refractometer factor, or was it 1.5? Yes, okay. That's 7.7. That definitely makes more sense.
Yeah, I guess so too. That fits much more into the picture. That's good. So, what do you do with this data? Do you digitize that somehow in a program, or how do you do that?
Yes, and in the end of the year, I scan it and then it's available on the company server.
Ah, that's your way of digitizing. You scan it and you keep it on the server. That sounds very interesting. So I think I have a much more modern approach for you, and I would like to show you that. Come with me, I'll show you.
Okay.
Yeah, Patrick, I promised you to show you something more modern than what you were doing lately.
Oh.
And let me introduce you the Liquidtool sensor.
Yeah.
So here, please hold this so I can show it to
Okay.
you. So we at Liquidtool, we designed a completely new plug and play coolant sensor. And what it does, it measures the concentration and the temperature automatically on a regular basis. Very simple, and the data is then stored in a managing cloud platform where you have all the values and all the history you need. So you don't need to write any papers, you don't have to scan any documents, you don't have to measure anything. You just put this to your machine and start measuring.
Nice. And where is this placed? In a tank or?
So I can show you how it's installed. It's very
Yeah.
simple. As I said, it's plug and play. So first of all, you connect the hose with a filter. I'll show this to our audience here. You connect that plug.
Yeah.
And then you have a return hose. Nothing else than a hose with a weight on it. So that's the preparation. And then we need power supply for the pump. So there's also a pump inside. Okay, so let me just quickly connect that. Oh, just have to tighten the safety screw here. And then we can install it magnetically.
Oh, nice.
So that's it.
It's simple.
Very simple. Then what you have to do, you add the filter and the return hose in your coolant tank. You can put it wherever you want. I mean, of course, we recommend the clean part of your tank, but it doesn't matter. We tested all areas. It works wherever you want.
And how can I connect this to the platform?
So this is very simple. So you can download the Liquidtool app in the App Store or in the Play Store. So it's available for Google, Android, and Apple.
Yeah.
And then you can connect your app over Bluetooth with your device.
Oh.
So when you have this connection, you can then do the settings. So it already started measuring. As you can see, it has some bubbles. That was because there was air in the piping, because we just installed it now.
Yeah.
And it does the pumping. And as soon as you have connected it, so you choose the network you have, the Wi-Fi or even over Ethernet, and then you add the password, connect it, and it's done.
Okay. Can I have a look?
Yeah, for sure.
Nice. That's a button, and
yeah, here you can start the measurement.
Yeah.
You can also start it from the phone or from the desktop. It doesn't matter. But normally it's set to like an hour. So every hour you get a measurement.
Oh, okay.
You can also change the frequency if you want. And if you just want to have a real-time measurement, you just press here and the measurement starts.
Oh, nice. Then what's this?
This is a very good question. So this here is an NFC token. So NFC is a technology, it's called near field communication. And we have a chip installed in this token, and you can scan it with your phone. So I'll just show it to everyone. And then it will show you directly the values you have on this sensor. The aim is to get very fast access to the data. I mean, in the past, whenever you had devices like that, you had very expensive displays on it. And like that, you're as close as a display and you can get the data. However, you can also just access the cloud, go to your machine, choose the machine and read the values. It's the same information. This way it's just faster. And you can put this magnetic token in front of your machine. So you can always just scan it and have your data available very fast.
Oh, okay. All well and good. But this works manually for about 20 years. And yeah, what's the benefit of the sensor?
That's a very good question, Patrick. And I would like to bring this question to our audience again. Yes, I see. That's an answer I hear a lot the last 20 years. It has been working fine. I understand, but everyone can improve. And we were able to improve a lot at our customers. And I want to ask you, dear ladies and gentlemen, could you please answer the next question? What do you think we improved the most at our customers? So thank you, Patrick, and see you the next time. Okay. And ladies and gentlemen, I will see you in the other camera soon. So let's see. To life. Any other answers? I'll wait a bit more. Okay. Again, I won't force it. I will just continue. Huh? All right. Yeah, I mean, tool life, of course, as I explained in the beginning, has an influence that is clear. And I made a summary of all the benefits we were able to achieve at our customers. So you see about which range we can change things at customers. And the first one is the coolant consumption, as I mentioned at the beginning. But in average, we were able to measure that at our customers, and we can say we saved the customers 35% of coolant costs. And that's actually not even true. That's 35% of coolant consumption we saved. There's even more if you consider the dumping costs and everything you have to encounter when you change a coolant sump. This is purely the coolant concentration. However, this has nothing to do, not only to do with high and low concentration, this has also to do with how much you take care of the coolant and how frequently you have to change the whole coolant. So if you take care, you don't have to change it so frequently. That has a massive influence on your consumption. Then secondly, we had one customer, he explained us, unfortunately we are not allowed to mention his name, but it was quite a large machine tool builder from Switzerland. So they had issues with their threading on parts, like 6 to 8 times a year, the threads, they broke. And they were investigating why do they sometimes break, and they figured out, yeah, it is because of a too low concentration now and then. And this customer told me for every broken thread drill, it costs them around 1,000 euros. I mean, with getting a new drill, that's probably the cheapest part, and getting it out, machine downtime, everything they lose around it, cost them about 1,000 euros. And so at this customer, we were able to save him 6,000 euros in the first year because he didn't have these tool breakages. Then tool life, that was the first answer I saw.
here we investigated with our sister company, Blaser Swiss Loop. So Blaser Swiss Loop, they have their own technology center where they compare different coolants and test the influence of the coolants on anything. But we didn't want to compare different coolants. We wanted to compare the concentration of the same coolant in an application. And this here is a standard application to compare stuff at the Blaser Swiss Loop. That is, you have a standard tool, standard process parameters, and you machine one line after the other. And then you measure the tool wear on the tools. And when you reach 200 micron tool wear, you say, okay, end of life. And that's what we did. So we did it first with a universal coolant with a concentration of 5%. And we were able to mill as far as 57 meters. So you have the baseline. And then we raised the concentration up to 9%, as you can see here. And we were able to achieve 80 meters. Same coolant, same tools, same material, same setup, only the concentration has been changed. And this led to a 40% increase on tool life. And I thought that was quite astonishing. Of course, we have done this on case steel, and it really depends on the material you use and the setup and whatever process you do. But for you as a takeaway, keep this in mind. The concentration really has a massive influence on tool wear. Then let's see how it was with the skin irritation. So we had one customer, he only wanted our coolant management system because he had one employee constantly falling out. He constantly had the skin irritation, eczema, and was not able to work, and that was really annoying for him. And we discussed that, and I said, yeah, maybe you're monitoring your coolant not properly, or I don't know, let's see, have a look. And then we put a sensor on the machine where this employee worked on, and see there, what we measured at the end of the day was something completely different than what was on the paper, as you saw in the video before, same story. And as soon as they monitored it automatically, they start looking at the concentration properly and improved the concentration level. And that was stable on I can't remember, I think it was about 8% they had, and it was clean, always on 8%, stable. And since then, the employee never missed a day out because of any skin irritation ever again. And last but not least, in all our customer interviews, one point in particular has been shown again and again. Since they manage the coolant with our solution, the perception of the coolant has changed completely. And the employees are motivated to maintain the coolant in order to produce chips in a clean and motivating environment. And that's a game changer when you see your people suddenly wanting to take care of coolant and taking care of coolant and having a wonderful environment to machine more parts in a happier atmosphere. Yeah. When I look at everything, for me, I stay with it and I stick with my statement at the beginning. The coolant concentration is the most important KPI in our machining industry. Thank you very much for your participation. I would like to ask you to bring all your questions and challenge, especially my statement. You can do that by entering the questions into the chat, or just open your mic and talk to me. We can have a live discussion. That would also be very nice. Up to you, and I'm looking forward to your questions. All right, there's already the first question. Do I have to clean the sensor? That's a very good question. So as you can imagine, coolant is something very complex, and yes, you can have residues in the optics. Generally, our experience with most coolants in the industry, you can let the sensor run for almost a year without doing anything. But if we have some residues, or we call it pollution on the optics, then you can rinse the sensor with a easy alcohol. You can imagine it's like cleaning an espresso machine from caulk. It's an easy, simple task to do that. And the good thing is the sensor realizes it on its own when it gets polluted. So it will give an information to the user and say, hey, I think I'm polluted. Please clean me, so I have clean values again. Good. Then there's another question. Does the device work efficiently in dirty coolant? Yeah, dirty coolant is a very wide definition, but what we did is we used very old dirty coolant, even from the machine you saw before on the picture, to test exactly that. The point is, or my recommendation would always be, if you install a sensor, clean your whole machine, get a new fresh start, everything clean, and then install it so you can keep it on a good way. The other way around, if your machine is already contaminated with bacteria, with fungus, it is very difficult to get this system clean again. It's not a problem for the sensor, it's more a problem for your machine. Who has access to the measurements? All right. Access to the measurements is very simple. The user who installs the sensor here will register online to create this platform with all the machines, and he has then access to the measurements. He can then invite employees and to also see the same data. So you can share your dashboard with anyone in the organization. Do you have to calibrate or zero the sensor like hand type refractometer? No, this will be calibrated from production site. And then, as I said, it has its intelligence and knows when measurements are not correct anymore. So you don't have to calibrate the sensor anymore, like the hand refractometer. Okay, are there any other questions? How to use the device if there is no VLAN in the workshop? Okay, if you don't have Wi-Fi in your workshop, you can also use Ethernet, so you can also connect it with a cable. Or what we also provide sometimes for customers is a hotspot, so with a SIM card, and then you can create a quick hotspot in your workshop. But to be honest, I like this question because we are in 2021. We're talking about Industry 4.0. We're talking about digitalization. And if you don't do the step into a Wi-Fi, then you're far away from digitalization. There's no way around it without Wi-Fi, and it's my personal opinion. I would love if you open the microphone and challenge me on that. Monitor more than one device. Yeah, you can monitor like, let's say you have a machine shop with 100 machines. You can install 100 sensors on all machines, and you have everything on one platform all together. You can even create reports for all of that. The system architecture is built up that you could manage and design the architecture of a company like Bosch or Airbus or whatever. I mean, size is not the problem. You can go as far as you want, and you can create
your own departments or business units and all connected, and then we have a whole user management behind it, who has which rights to see in which shop. So you could have a global view on all your production sites if you have a global company. You're welcome. All right. If there are no further questions, I would also like you to visit our booth from the DiMaP. There is a link where you could book and we can have a one-to-one discussion if you want. You can also do that on our website. There's the link, and we will even post the link in the chat, and you will have an information at the end of this presentation. I would be very happy if we could have further discussions one-to-one, and I invite you to book a meeting directly with me. Thank you very much. Enjoy the rest of the DiMaP and hope to see you soon, probably at the EMO. I will be there. I would love to meet you there. Thank you. Goodbye.